Good afternoon, everyone. I'm Nikhil Nanivadekar. We are here to discuss about unlocking the power of generative AI and simplifying ad content creation. So it's written as ad content creation because, as you can see, I work in the creative tech of Amazon ads. But the concepts that I'm going to discuss are not just something for creative tech or for ads, but I've created it at an abstract level that you can take at least the patterns and use it in your day-to-day life if you're working with generative AI. With that, in the next 60 minutes, we'll explore sort of the evolution of Gen AI, how it has impacted Amazon, the things that we have done, and then I like to go super deep in actually the tech. I'll take us through some of our actual behind the scenes working, going deep in the architecture as well, and showing a few demos. So it should be fun. This is one of my favorite presentations to give as well, and it's the whole idea is how do we build reusable software and use patterns for generative AI integration. With that, real quick, I'm Nikhil Nanivadekar. Like I said, I'm a principal engineer in creative tech at Amazon Ads. The presentation is not just about the architecture as well, but it's also about sharing the evolution that Gen AI has had over the last, I would say, from end of 2023 onwards. And over the past year, we have seen businesses use Gen AI in an incredible way. And they're taking advantage of all the AI technology to drive performance and also to create a good experience for customers. So let's dive deep now. If you look at it from 2023, we're actually witnessing an extraordinary technological transformation. If you see, it was, I regard 2023 to be the year of proof of concepts. Folks were sort of talking about Gen AI. It was in the media. It was sort of in the social media as well. It was a pretty emerging concept. And enterprises, organizations, even we as users, we were kind of trying to figure out what exactly it is. And there were certain fundamental questions, some of them were what is an LLM? What are models? Where do we start? So on and so forth. And if you see the evolution to 2024, I regard that as a year of production. So the conversations have fundamentally changed from, hey, which model do I use versus hey, how do I productionize something, right? It's kind of the internet where now we just take it for granted that we get really high-speed internet on our phones, right? We can watch movies, spend time surfing the web even on our phones, right? But this wasn't the case all the time. So you can see that evolution happening, right? And so the whole idea has been how do we scale? How do we accelerate innovation? And just sort of putting it out there so that you get to see the offerings that at least AWS has, Amazon has. As you can see, we have Amazon Q, we have the AWS App Studio. I'm a big fan of Q, especially when I'm writing code, and I know that it's not 100% right all the time, but I'm going in with the expectation that it is not 100% right all the time. So some places where I actually effectively use Q is to write unit tests, where I can just select a function, a method, so to say, and say, hey, Q, can you please write some unit tests for me and break it up into separate tests for different scenarios. And it does a pretty good job. And most, for me, the most productivity gain is it is taking care of the boilerplate work that you have to do, even writing the ad test, coming up with method names, so on and so forth, and setting up the setup data and stuff like that. So and the same thing is available across the board. I just personally use Q. Then there is Amazon Bedrock as well. Again, I'm not making it a sales pitch. It's these are the things that I'm using in my day-to-day life as an engineer while I'm writing code. So just it has fundamentally changed the way I am actually developing. And if you all have not given it a go, like just try it once and try it with the expectation that it's not going to be 100%. Like, so take it with that pinch of salt, and it actually is kind of liberating. Um, with that, certain things that, like I said before, like the pace of technological advancement is actually remarkable. And similar to what I gave an example of the internet, it's also the PC revolution, the personal computer revolution, where it started out with like, hey, what is this computer thing, to like now we just knowing that like all of us have laptops in our backpacks, right? It's like that. Especially coming from India, like where I mean, I used to have that big machine, and now all I have is a laptop. Like I don't have the big machine out there. So it's sort of like the similar inflection point with Gen AI, but the biggest thing to note is the timelines are compressed, because a few things are happening where there are more people who are actually developing things, and then there are also the technological advancement is also fast. So like if it took 10 years before, like now you can see it's a compressed time frame. So just remember that when you're looking at it, the years that were allowed for gradual evolution and adaptation, today's pace is like astronomical. So what we did was last year we introduced Rufus. How many of you use Amazon.com like to do shopping? Cool. This is encouraging, pretty much. So if you have tried out Rufus in there, or give it a shot. It's pretty cool. It does a fairly decent job. It does a pretty good job, and we keep on doing updates to it. But Rufus has been trained on Amazon's product catalog, so it's helpful to answer questions, compare products, and so on and so forth. I use it fairly regularly, and in my opinion, it does a pretty good job to at least get me to give me information. Um, Similarly, in fulfillment centers, we have been using Gen AI for especially the documentation purposes. Like if you think about it, you have got like thousands and thousands of pages of just literature on trying to figure out how to do something, and then just making it easy for giving references, asking questions, versus relying on just pure tribal knowledge. Like, so it's kind of like quite interesting in terms of how we are gaining efficiency, right? And then similarly, for even training some of our customer service agents, we are using Gen AI so that we can actually accelerate the skill set development, right? And now at this point, you'll be like, hey, Nikhil, you're talking so much about like Amazon and all the offerings. This is about generative AI and content creation. So what I wanted to say is like, these are not just technological improvements, right? They represent a fundamental reimagining of doing things. And so back in 2023, we actually launched a product where we wanted to make it easy for advertisers to generate images. At that time, like even generating images was like the first step, right? And the reason why we wanted to do that was, again, you want to reduce the friction, you want to make it easy, and you want to actually make your ads kind of stand out. Like when an ad is shown to a customer, and when, let's say I'm a customer and looking at the ad, actually want it to be like high quality. I want to feel that like, premium effect that is there. And so we started that journey. And if you look at a typical search result page, like when I asked before, like pretty much everybody had raised their hands that you shop on Amazon. So when you go on Amazon, let's say you search for men's running shoes, you get something like this, where the results have details like a product image, product name, price, prime promise, etc., etc., right? Now, as a shopper, when you're scrolling through it, right, and I'm talking about even like me as a shopper, when I'm scrolling through everything, right, I want my shopping journey to be like someone to aid my shopping journey. Like I want to get the necessary information, like, what is the star ratings? Is there a bestseller batch? Is there a deal going on? And all of these are important components of a search result. And for example, a typical product detail page on Amazon, it has a product shot, it has descriptions, delivery timelines, customer reviews, right? Now, if you look at it, an exemplary product detail page would have addressed the purchase barriers, it has descriptive content, it tells a great brand story, and provides new, precise, and non-repetitive information. More than anything, it also needs to have a highly impactful, high-resolution image. Like the first thing that catches anyone's eye is like how good it looks. So you need that high impactful, high resolution image. So that's where we actually found that like, hey, there's a content gap, and that content gap is the creative barrier. So there are multiple ways to engage with shoppers where they're spending their time, like both online as well as offline, like where they're in their shopping journey. But in order to draw meaningful engagement and like attention, you need to like figure out a way to deliver visuals that are on brand, right? And they also need to be timely and relevant, right? Now, the reality is, and when I'm like working in advertising and I'm talking to the advertisers, the reality is that it's a huge investment. Like the advertisers have a lack of time, they have lack of budget as well, because it costs money to produce that, it costs resources as well, and it needs expertise more than anything. Because like if you want to know like how you're going to take a picture, you also need to understand like how the lighting should be, how it's going to have like very good placement, like so on and so forth, right? And then more than anything, what we discovered was like even stale content fails to grab the attention, because, and you also need it to be seasonally relevant, right? The reason why you need it to be seasonally relevant is because think about it this way, like during the Christmas holiday season, you actually want content that is like, more suited to the Christmas theme. When it is Valentine's Day, you want the Valentine's Day theme. Then there is like Mother's Day, right? Now imagine all through the year, you have all of these seasonal events that are going on. And if these seasonal events are going on, like imagine the overhead that the advertisers have to keep on generating that content. So we figured, what if we could actually create a way in which brands could just, instead of starting from scratch and building everything, we can do it with the press of a button. And this is what we launched back in 2023. Let's just look at the video of what we are doing. And it's quite straightforward advertiser flow where they select a product, decide that they want to generate an image, and then they get a prompt now where choose an AI generated image. And our AI generates up to 4 images and they can select one. Once they have selected, they can add it to the campaign that is there. And then the same campaign actually for all of us as shoppers, it shows up on our, like let's say, search results or on our product detail page. So at this point, you all must be thinking, okay, Nikhil, cool. How does it really work? So let's look at the architecture at a high level detail, okay? I always like to first show the end product of what we have delivered, because then I can bring back to fit into how exactly it works. And we are going to go like really deep in, even in the inference generation. So advertisers enter through the ads console like we saw. When advertiser wants the generative AI image, we trigger a process in the backend. It's like behind the Lambda orchestrator that is there. And using the Amazon product details, because if you remember in that video, we did not have the advertiser enter anything. They just selected the product and we generated the images. So it's like we wanted it to be as frictionless as possible, and it needs to be a click of a button. And the output that we get is a set of images shown to the advertisers, as we saw in the video before. But you must be thinking, all right, Nikhil, this is cool. How does it really work, right? So let's actually go in the image generation inference process. So behind the scenes, what ends up happening is, if you remember the previous slide, you get the Amazon product detail page, and then we also allow the advertisers to input any prompts or any details if they wanted, okay? And then in the whole workflow, we take the product salient features out of the product detail page that is there. Like for example, if it's a running shoe, if it is like, extra cushion and so on and so forth, stuff like that. Then we also select the product image from the product detail page that was given, because one product can have like, as when you all are shopping on Amazon, it can have multiple images. So we select one of them, and then we actually found during our prototyping that we need like certain pre-processing and post-processing steps. We also make sure that our outputs are responsible AI compliant. So they also go through the RAI filters, and then and only then we surface it to the advertisers. So now, for example, like if you look at this, the product image segmentation step, we got the product from the we got the product image from the product detail page. But what we have to do is we have to take it, and then we have to separate the background and the foreground and actually identify what exactly is the image of the product. Okay, and we use like anywhere you see like a symbol like that, that's basically an ML model, a machine learning model, or a generative AI model, and they have been annotated accordingly. So we use ML models to segment the product shot from the background, and then pass it to our then we pass it to our inference stage, or our image generation stage. So now what we have is we have the product shot, we have the salient features, we also have the advertiser inputs, and that goes in through our responsible AI filters, because we want to make sure that even the inputs are responsible AI compliant. And then after that, we have our finely tuned LLM to generate prompts. Because remember, the advertiser didn't have to enter anything, but even in case they do, we respect that, we take it. And using those prompts, we actually generate sort of concepts. And then for every single product that is there, we end up, for every single image call, what we do is we end up generating multiple prompts. So in this case, there are N prompts. Okay, and those N prompts end up triggering the text to image generation model that we have, and each of that prompt generates M images. So what happens is at the end of it, we get a Cartesian product of M times N. And again, this is done so that advertisers get the variety of images that are there, because you have different prompts coming in which have like different concepts. Then each concept can generate like different images, and it just sort of increases the diversity that we are going to surface to the advertisers. And lastly, it goes through the responsible AI filters, and we surface to the advertisers. Now this is how the entire image generation workflow is structured, right? But we did not start out like this. Like this wasn't like, this is like a few months of us developing and figuring out, right? So how did we really get there, right? It's sort of important to understand behind the, it's sort of important to understand behind the basics of like, how did we even get to this text to image generation model, right? How did we come up with like, I didn't wake up in the middle of the night and said, hey, this is how the whole inference workflow should be, correct? So any ideas of how we must have come to this? Well, the whole idea is like, there's one word answer for it. It's actually prototyping. We literally prototyped multiple different ways in which we generated all of these images. We had a set of scientists, like different scientists work with different models. We had different approaches that we were trying out, and then prototyping and iterative development was the way to go. We actually iterated on multiple models. Some of them were one shot. Some of them we had to daisy chain to figure out like, what's the order in which we invoke the models. For us, like SageMaker actually formed the central part of our prototyping, bench, so to say. And then that allowed us to have like the model registry. It allowed us to expose the API endpoints. And that way, what we could do is we could also identify them at scale, whether the outputs were good or bad. Because remember, it's highly subjective, like if an image is good or bad. right? Some of the images, like, you clearly see, oh no, this is really bad, or this is really good, but like actually doing it at scale, especially at the hyperscale of Amazon, that does take us to also evaluate them at scale, right? Um, so for that, we use SageMaker Ground Truth, where we could just evaluate the images, whether something was good or bad. So going back, the iterative development is what led to the workflow, which we saw here, right? And then that's not all. If you remember before, like I said, we make sure all the outputs that we are generating is actually going through responsible AI guardrails, right? So we even created a way in which we could bookend our workflow with responsible AI filters, right? And the responsible AI filters, actually, we figured a way in which we could create a process such that we could use some of these technologies that are already available to us to make sure our inputs as well as outputs were responsible AI compliant. Maintaining customer trust is extremely important. It's paramount for us. So at a super high level, this is how like our responsible AI guardrails are. We use AWS managed services, and essentially they have the Amazon Bedrock guardrails that are there. Then we use recognition, comprehend, and as well as some custom rule-based filters. So for example, the Amazon Bedrock guardrails help us detect sensitive content like PII, define some denied topics like, hey, we are not going to generate anything for these specific content or some topics that are there. And we use filters both input and output for the foundational models available in Bedrock. Secondly, like I said before, like we use Amazon recognition as well. This helps us detect inappropriate images and videos, and it categorizes the assets that we have produced against categories of images that we do not allow. It also helps us detect celebrities, text on images and videos, and so on and so forth. The Amazon Comprehend detects PII information, like if there's any sensitive information in the inputs or the outputs that we have produced. And lastly, we also have custom rule-based filters, which we use for fine-grained control. Let's say like if you want to have some specific fine-grained control for the guardrail, we can just add it in our custom rule-based filter, and it just takes effect. And so this is how it constitutes the entire image generation inference flow. And I'll tell you this, we built this as a purpose-built solution for text to image. Okay, like we did this in 2023, but like every purpose-built solution, it can only scale so much and it can only support so many use cases. In my opinion, it did a phenomenal job to help us deliver image generator back in 2023. It was like one of the flagship launches of Amazon, and I'm really proud the way we developed it. But then in 2024, we needed to scale our offering to support the hyperscale of Amazon, right? So we decided, all right, we need to offline bulk gen all these images. So what do you all think? Like, did we have to redo the whole architecture again, but to do it at scale? Yes, no? No, right? Like we don't. So all we did was we just used the AWS multi-account strategy, where we were able to just create new accounts and then deploy the same infrastructure inference workflow out there. It also allowed us to isolate the online calls and the offline calls, and this was super important to us because again, maintaining the customer trust as well as the customer experience is of paramount to us. So on the advertiser side, whenever they're working directly in the console, we consider that as the online flow, but that we did not want to have bottlenecks in that because someone is actually using it, right? And this also allowed us to have independent scaling controls, like this separation of accounts, because during, let's say, peak events, because the online and the offline processes were isolated, during peak events, we only had to scale up the online process, make sure that we had enough capacity for that. And then we could scale that down while the offline process, like, that continued to go. AWS also provides the CDK or cloud development kit. If you have not tried it, like, give it a try. It actually provides reproducible environment. So it's as easy as it really gives you very high flexibility. So it was as easy as just creating new accounts, like I said, and deploying the same code there. Okay. So just to summarize, we essentially prototyped, and it was fast and iterative prototyping. We prototyped our way to the solution that we launched. Like, now you might think that Amazon is like, this big, huge company which has limitless resources. But let me tell you something, like, very frankly, that's not how we operate. Like, it's like, even though you might think that it's a huge company, it's our startup culture that actually enables us to have ambitious goals. But we have a 2-pizza team structure, which allows us to be scrappy. It actually requires us to be scrappy more than anything. So we start out small, but with big goals, and we have iterative prototyping, and that's how we deliver the solution. For us, it was the SageMaker made the centerpiece of our inference platform, and as well, like, we directly deployed our models onto SageMaker. While we knew we would want to scale to other offerings, but like I said before, as a startup, we were kind of thinking about a purpose-built solution, which we did for image, and that's how we innovated and delivered. We were also cognizant of the fact that Gen AI was evolving super fast. So our optimization function was to essentially prototype and deliver fast, push it out to our customers as fast as possible. We invested in responsible AI guardrails. We created responsible AI as one of the building blocks that we use across, like, our inference flows, so that the inputs and outputs that we are producing are actually RAI compliant. The one thing that our prototype showed us was like a composite model. So as you saw the workflow that was there, that's actually a composite workflow that yielded a much better results for our customers than a single model would have. Okay, so let's see how it was in action, right? This is how it was in Q1 2023. Now, Q1 2023 was 2 years ago. Okay, and the prompt is quite straightforward, a close-up shot of a worn-out baseball in dirt, right? If you look at it, the image sort of vaguely resembles baseball. The dirt, like, you could squint and say, yeah, this is like true to the prompt, but it really is not. Let's be honest. Let's be realistic here. But this is our latest output, right? The output actually resembles a baseball. It actually has kind of realistic wear and tear that is there. The dirt is also pretty, like, real. So you can see that, like, we have come a long way. The tech has come a long way. Gen AI is evolving at a very high pace. And, like, not just this, like, let's look at another example. So back in 2023, a prompt like this, 3 oranges on a railing with sun setting in the background. Like, I mean, yes, there are 3 oranges. Yes, there is a rail. It's on the oranges are on the railing. This seems like a soft sunset light, but you can, again, even if I were to squint, like, I'll be like, okay, no, this is not really what you would want to put in front of customers, right? So, I mean, sometimes I look at these back, like, there's nostalgia of, like, hey, like, it's just funny, but it was a lot of cool, like, innovation at that time, because us having to have that high standards actually made us push the tech and science to evolve into what we have now, right? Where now there are actually 3 oranges. They are, like, properly setting. You can actually see the shadows of those oranges as well. And by the way, this is, like, we haven't like, done any sort of Photoshop or, like, touch-ups or anything. This is what the models are returning. Now, like, you can see it's actually a sunset behind, right? So you can see we have actually come a long way. But then me as an engineer would always ask, like, okay, but is that it? Like, can we do more? So starting with the product detail page, we created some stunning imagery, right? You saw the images that we do. But then there's more. We thought, can we add some subtle animation to the image so that like it will actually be sort of eye-catching. If you look closely, there's the candle flame that is moving, right? It's that flickering candle flame. Or another example, if you wanted to push the boundaries, like what could we do? So this like body cream ad that is there, where like it has lavender fields, but then you can see that we can pan them. Then we can pan the camera. You can see them swaying in the wind. It's pretty cool, right? Similarly, like this, by adding sort of subtle camera motion, or as we like to call it, parallax effects, how can we bring these images to life, right? Like that's what we were looking for. Like how can we actually do something that like the customers will enjoy? So what we do is we take the AI generated images that were there, and with just a click of a button, we apply fluid camera movements or subtle depth effects that make the visuals pop. So for example, and you can see like, this is all just with a press of a button. So if it is a steaming cup of tea of your favorite beverage, any coffee drinkers out here? Or like a bouquet of flowers, in this case, or even the night sky. You can see the realistic motion of the night sky, or it can be the crashing waves on the beach where you're listening to music. This is all possible with Gen AI, and these models, like that's what we were developing. So do you want to know how we did this? The live image? Yes? Okay. Really yes? Oh, nice. Okay. That's what I like. So this is the architecture. Now you'll be like, oh, Nikhil, what is it? Okay. So what we did was we took the image and architecture that is there, and then you all have already seen this. We spent the last 30 minutes in looking at the image and architecture. And then we added a few more steps to bring these images to life. Okay? So we generate these images and then add depth to the images to convert them into video, and then use an image to video model to convert them to actually that adding those subtle motions, right? So if you recollect, we had actually built a purpose-built solution that was there for image generation, but like with every purpose-built solution, it can only scale so much. Like I was extremely proud of what we did back in 2023, but then functionality like this was coming up, right? And then it wasn't going to stop like at just live image. Like we also needed to give ability to advertisers to change their images if they wanted to move where the location of the product was there, if they wanted to even change the background, like essentially being sort of things that we wanted to provide to the advertisers, like having a purpose-built solution was not possible. So for example, in case of this image editing process, like what we needed was an LLM-based prompt augmentation, because we get the input from the advertiser to say, hey, the advertiser would say, hey, I want this to happen. But then we need to augment that prompt so that we understand what exactly the advertiser wants. And then that is passed in the editing model so that we get the output, right? Now you can see, in this case, just prototyping was not enough, right? Because all of these new functionalities were like sort of were required. We needed, and we could not build, like how do you scale all of these offerings? You can't go on building purpose-built like solutions for each of these. And the other part of it was with generative AI, like it's such an evolving field, like we didn't even know where we are going to get to, right? So in that case, you sometimes have to just take a step back and rethink, right? And then what we thought was it's extremely necessary to rethink our process to not just do prototyping, but to go from prototyping to production. Because if I just prototype on my laptop, everyone else is not good. Like I have to give it in front of put it in front of our customers, give it in their hands, right? So we inspected the entire process to identify the bottlenecks, right? And the biggest bottleneck that we found was our scientists would come up with different prototypes and set them up in their notebooks. But to take the prototypes to production or to make them production ready would be an additional effort. So just because it was sort of the works in my local situation, right? All of us have done that, like, hey, it works in my local, right? But then when it's production, things changes, right? So, and there would always be a consistent back and forth between the scientists and engineers, because the engineers had to take the models that they had developed, actually get productionize them, and after productionizing them, test them out and push them out. The engineers had stuff like model registry. If they had to stitch different models together, they needed to do that. They had to define the workflows. It was essentially such a there was a lot of redundant process. It was a lot of heavy process, right? And then the other biggest problem was the engineers would sometimes have to redefine the workflow so that it would work. Now, how many of us have gone through a lost in translation situation? Raise a hand, right? And what I mean by lost in translation is, like, let's say one of your colleagues tells you that, oh yeah, just expose an interface like this and make this contract like this, right? And they just say it out loud, but the contract is not defined. And then what do? Like, oh, I expect that these are the inputs that are required, and these are the outputs that are required. Sometimes even smallest of small things, like, for example, account ID versus ACCT ID. Will your API work if the JSON had incorrect fields? Yes, no? No, right? Exactly. So now that's the lost in translation, because now if you go and see that back and forth that was happening, that was actually really expensive, right? And then at Amazon, the biggest problem was, like, we wanted to do this. We wanted to expose it at hyperscale, and we wanted to operate at as a startup. And what started happening was, like, we realized that, like, the biggest problem out here was that, like, this handshake that was happening between two different sets of people was actually hurting the process than helping. So then we said, okay, what can you do? Now that's a great liberty of, Amazon is, like, it gives you the ownership and agency to actually do what you want with the process and how you fix the problem, right? So we decided, all right, we are just going to simplify the process. What if we could streamline the development process such that, like, the scientists and engineers didn't have to sort of have this handshake? Like, scientists could just build the models like that, the way they are building. Let it be in their Jupyter notebooks, in Python, or whatever. And then the engineers were writing the code to actually interpret what models they have built. So what that leads to is, you don't need to have this handshake of every single workflow being deployed. Because imagine, so for image gen we had one, then for live image we had another one, for editing we had another one, and then we are going to see some more architecture diagrams like later. So just think about it, right? Like, think about the scale that we are working at Amazon. If we had to do all of this, and each of these innovations required that heavy handshake. So we just simplified the process. What we did was, the engineers would build the system such that it removed all the repetitive work that is there. And in this case, like in Amazon, we like to work backwards from our customers. So we said scientist is our customer in this case, right? And then we built an intuitive Python based environment where we get to encapsulate all the workflows. And these workflows are nothing but a composition of tasks that are written in Python. We chose Python because that was the language of choice of the scientists. They're like, yeah, we work in Python, we're just going to use Python, so to say. And we're like, cool, you're the customer, you want Python, you got Python, right? The environment auto pulls AWS resources like Lambda, SageMaker, DynamoDB, so on and so forth. And it also provides a way to simulate AWS services locally. The other thing that we wanted is, like, whatever the way it runs in my local, exactly, I should have that deterministic way to know, hey, if it works in my local, it's actually also going to work in production. And the works in my local problem, I just wanted to get it out, right? So all the scientists had to do was put together their workflows in this declarative fashion. We added the separate annotations like at workflow, at task, and so on and so forth. And these annotations allowed the scientists to encapsulate all the logic. If they wanted one workflow to call another workflow, if they wanted to daisy chain tasks, they could do all of that. And then the scientists could focus on building the workflows as separate tasks, and we're going to see them in a couple of slides. And then the engineers actually innovated to refer to this input that was coming in, this declarative workflow that was there, and then using that, it essentially allowed them to build an AWS Lambda orchestrator. What the orchestrator did was, or does rather, is it interprets the workflow from the SDK that the scientists have written, and using custom annotations in that SDK, the logical sequence is planned, okay? And accordingly, we generate a workflow graph. So now this workflow graph is nothing but a blueprint, and this is a blueprint for execution, right? And then finally, based on the workflow setup, we pull in whichever AWS resources are required and do the invocations, right? In this way, we have the scientists define the workflows declaratively, and then the engineers are able to, and the beauty of this is we only have to write the declarative to deterministic conversion step once. So the scientists have defined the workflow in a declarative way. The engineers have written the interpretation. So the declarative workflow gets to execute in a deterministic way on AWS. Now, let's actually look at how we define the declarative workflow. So if you remember previously the live image that was there, we are going to work through how actually the workflow is, and this is pretty much a code that is coming from what's running right now. So it's a standard, this is a method definition, this is your request, that's going to be your response, and then you have a return statement at the end. And now you want to have product info that is there. In Amazon, the product is called as an ASIN, so that's why you have ASIN here. And then if you need to process the image, you get to process the image, and then you want to generate the live image, right? And sometimes you want to enhance if it is required, because remember, if the resolution is low, you want to upscale it to make sure you have high resolution, right? So that's it. This is all, and these are all the tasks that the scientists, and this is what comprises the workflow, okay? And now looking in one task, and again, I just want to dive deep in the task so that you all understand how we are writing the code as well. So in this case, this is the task to generate live images. It's quite straightforward. It takes in the inputs, some parameters, and a predefined model. So you can see the model, it's called live image v1. And it invokes on the model. Now this is super important. And this is the beauty of declarative style of development. We don't specify whether it's going to be a Lambda invocation, whether it's going to be a SageMaker deployment, whether it's going to be a Bedrock invocation. We just say, hey, this is the model, invoke it on the model, right? The system should just know how to invoke it and what exactly to do based on what model it is. In this case, the model contains the necessary information that it is a SageMaker model. And so if you want to see how the invocation happens is, and before we will see the invocation, I just want to show some of the one-step environment setup as well. Because this is a SageMaker model, you also need to do some initial environment setup. But because now this is classified as a SageMaker model, for all SageMaker models, we have to do write this code just once, right? Which is you're setting up your environment, if essentially the region, which sort of which phase of the development are you in? Are you in Devo, Beta, Gamma, Production, so on and so forth. And this way we just abstracted the SageMaker setup so that even this minimal environment needed to be set up only once for everybody, for all workflows. So that's what makes it sort of it's super easy, it's efficient, and it's effective. Now, looking at the invocation, if you remember, we just did model.invoke, that's all it does. It does invoke real time, passes in the payload, and it runs on SageMaker. Now, only for the presentation, I've not shown the async flow, but async flow is also something similar with the necessary other things that you need for async, like checking the status, doing the polling, and so on and so forth. But again, the whole beauty is it's only written once and it can be done It can be invoked for all the models over and over again. And you would also, if you remember, in the workflow definition that was there for the tasks and everything, there weren't any logger statements. There weren't any error. There wasn't any error handling, right? Do you all remember seeing the loggers or error handling? Because you don't need to have this. You don't need to expose that for the scientists. Like this should come as a part of, the SDK itself, and that's what we do. So like even in the standardized invocation, like again, to save space, like this will be wrapped around the try catch block, so to say, so that if any exceptions are there, they can be handled. Stuff like the AWS clients, and that is sort of Boto 3, which is a runtime client that we get. Like using that, we can just do the necessary invocation. Isn't that amazing? Like it's completely abstracted out. Like that's the thing, like all the logic that is there, it's encapsulated. Because if you remember, we actually went back and inspected what was it that exactly was holding the scientists from pushing it to production. What was that handshake? And then when we discovered, it's like, okay, all of these things, you can just abstract it out. And that's what we did. This really makes me happy. Like as an engineer and an innovator, being able to just abstract, this just gives me joy, and with sort of that approach of declarative style of coding, we were able to deliver all of these. Like there was image generation already. We upgraded that workflow to use this style of programming. We have editing, live image generation, image product resizing, styling, and themes. But then we were asking, could we do more? Right? Come on, this is not enough. Is it? You think it's enough? No, we thought it's not enough. Like we need to do more. So last year, we also launched video generator. Exactly like the image generator, the advertisers can go to the advertising console, select their product, and generate a video. Let's take a look at it. That's it. Select the product and say, generate the video. We generate 4 different videos with headlines. Again, all at a click of a button, right? For me, this is what innovation is, right? It should be fast, it's easy, and it's for our customers, right? Do you want to know how we solve all these complications so that, do you want to see the inference of video? Yes? I didn't hear it. Yes? Okay, let's see. So, and you will see there's a theme to this, right? We took this is a live image generator architecture. We took that and we decided to add a few more workflows, right? And to get this going. So for example, one is the text to image to video workflow, which takes in the prompts, generates images, and converts them to videos. We also have a text to video model where we just pass in the prompts and it generates a video. In parallel as well, sorry, my transition didn't work. In parallel, we also generate headlines. So now we have headlines, we have a variety of videos, and the videos and headlines are actually passed to our video renderer. As you can imagine, that because it's a video as well as it has like additional text content, it is like the payloads are larger. So for that, we use AWS Fargate for our video rendering. And then, so our AI analyzes from the left-hand side, it analyzes the videos, it writes a script, it generates a prompt, and using that prompt and those images, we generate the video. Completely automated, okay? There's no prompt engineering for the advertiser required, okay? Now from all of these, you can see that there's a consistent theme. We make it simple for our advertisers, we make it simple for our customers, so all they need to do is click a button and our AI does rest of it, right? Now zooming into our text to video model, we actually announced this at last year's reInvent. We use something called as Amazon Nova Reel. It's available on Bedrock. You all can try it. And we use it to generate 6-second videos, and it's a text-to-video model. So now, real quick, let me show you an example of a whimsical world of pasta, which we did a video of to while I was preparing for this presentation. So you can see like there's meatball dividers out there, some cannoli. Right? It's a fun and a creative story, right? Like it's kind of different. I mean, I would not have thought about a pasta village, and that's what the AI actually, and that's the thing. That's the kind of like the innovation and the progress of these solutions. And remember, this is just the start, right? Like we're just about a couple of years in the journey, right? It's only going to get better as the capabilities evolve. So, okay. So we also decided that, okay, we have all of these functionalities. So for our advertisers, we wanted to give them a single place where they can conceptualize, generate, and refresh their ads. So using simple product shots that are there, we generate concepts that are there. So for example, in this case of a coffee mug, we generate all of these different concepts that are there. And you all saw the actual infrastructure, like inference layers and the workflows that are there. These are the ones that are used. And like, for example, if you want to choose the Zen-inspired one, you can pick the Zen-inspired one. And we also give them a creative dial where they can decide how much Zen it needs to be. And if they think it's too much Zen, they can like reduce it all at a press of a button, right? They don't have to go on redoing it over and over again. And that's the thing, it's in a few seconds. And then pressing a button, you can add, some subtle motions or even create a video, right? So that's, for me, that's so powerful. And it's all based on the infrastructure and the workflows that you all just saw. How cool is that? Pretty cool, right? Now I'll be like, okay, but you all did all of this. How has it helped customers as well as businesses and all of those? So what we found was, after we started doing all of these, brands that were using AI-powered creative solutions were actually seen to advertise 5 times more products, okay? They were able to use twice as many images per advertised product over those that did not. This allowed them to expand their advertising campaigns and experiment with different and new strategies. Also, because when we launched this generative AI solutions, advertisers that used AI-generated creative solutions actually experienced an increase in the return of their ad spend of 17% on average over advertisers that did not. Advertisers who began using AI-generated images in sponsored brands, which is one of our ad products, saw nearly an 8% higher click-through rate. So the customers were actually liking these images and they were clicking on there, an 8% higher click-through rate on average than those without these custom images. The advertisers who began using image generator on sponsored brands saw an overall 4% lift in sales on average post-adoption versus those that did not. Also, sponsored brand advertisers that use image generator submitted 88% more campaigns than the advertisers who did not. So you can see even the folks, what we have built for, the people are actually liking it, and these data metrics actually show that. And now with that, I do want to end with some of the key takeaways. And again, these takeaways, I've purposely made them to be more durable so that you can use it even for non-Gen AI applications, so to say. The first one for me was, it's super important that you separate offline versus online calls. This way you can have independent scaling controls. You can isolate traffic so that you safeguard your online requests that are there. The SDK working model that I described, where we simplified the process, we came to that by understanding, identifying, and decoupling. So if there are any processes like that, you should go take a step back and actually look at the process that is there and see how you can simplify it. For us, Lambdas were extremely fast to prototype, test, and iterate. We use Lambdas in async so that it avoids idle time and basically optimizes the use of resources. We use AWS Fargate for long-running processes, as well as some processes that are heavy, which need more memory. Lastly, this is super important, and this is something that I have embraced as an engineer quite a bit, is infrastructure changes are bound to be necessary, right? That's pretty much a reality of life, right? But it's super important that you have encapsulated and abstracted things enough that those changes are completely transparent to your stakeholders. So you can always look at who your stakeholder is. Sometimes it can be business, sometimes it can be other engineers, sometimes it can be scientists. So it is like having that approach is super important. Okay, with that, that's the end of the presentation. Thanks a lot for joining, and I hope you all enjoyed it, found it informative. Okay, and enjoy Devnexus. Have a good one. Thank you.